Hi, my name is Shashank Singh, and I'm going to be presenting my Lab 1, which is charged tapes, for my Physics 2212 class. The purpose of the following experiment is to use charged pieces of tape in order to calculate how much excess charge remains on one of the pieces. Important ideas that I have employed in this experiment include electric fields, Coulomb's law, vectors, and gravity. Useful formulas that I have employed include the formula for Coulomb's law, as shown on the PPT, the formula for the electric field, the force on a charged object, and the force of gravity on an object. The assumptions that I have made include the tape is treated like a point charge at the center, and no friction or drag on any moving part is considered. The methodology of the experiment is as follows. A piece of tape Y was stuck onto a table and then pulled in order for it to exchange electrons and get charged. The tape was brought close to a negatively charged pen and a book with no charge. It was then placed below tape X in order to see the distance that tape X floats, and that distance was measured. The data for the mass of the tape was collected to be 2.2 into 10 to the power minus 4 kilograms. The length of the tape was measured to be 0.2 meters, which is 20 centimeters. The width of the tape was measured to be 0.02 meters, or 2 centimeters, and the separation between the tapes was measured to be 2.7 into 10 to the power minus 2 meters. Thus, the area of the tape was found to be 0.004 meters squared. The area of an atom was found to be 1 into 10 to the power minus 20, and hence, by using all this data, we were able to calculate the number of atoms on the tape to be 4.2 into 10 to the power 17, and the ratio was found to be 1 electron to 5 into 10 to the power 6 atoms. Assumptions made throughout the experiment include the following. Air resistance was ignored. The tape was measured to have an evenly distributed charge throughout, and the tape was assumed to behave like a point charge. The observations made during the experiment include the tape was attracted to a negatively charged pen and a book with no charge. The tape was repelled by another piece of tape. Conclusions brought about by these observations include the tape lost electrons and hence was positively charged. The results of the experiment include both of the pieces of tape repelled each other, telling us that both of the pieces of tape must have had the same charge. The charges in pieces of tape were found to be 1.3 into 10 to the power minus 8 coulombs. The deficiency on the tape was found to be 8.4 into 10 to the power 10 electrons. The following is the first computational model for GlowScript, where we consider both the pieces of tape to be point charges and calculate the force in between them. The following is the second computational model of GlowScript. If you would like to read the whole script, please pause the video. The only difference between the first model and the second model, majorly, is the distinction between the first model being a point charge, whereas the second model, the tapes are represented as lines. The following slide correlates to the what if and why questions which we were posed to answer. So the first what if question is, what if the signs of the charges of the tapes were reversed? What if a negative charge became a positive charge? And in my opinion, the observations would remain the same, as the like charges would still repel and the opposite charges would still attract. Hence, this would just be a question of semantics, as even during the origin of naming of the charges, if a negative charge was called a positive charge, all the physics in the world would still remain the same. This is more of a semantic issue. Thus, there should be no difference in results. The why question relates to the difference between the first code and the second code, and the answer to that is as follows. Code 1 assumes a point charge, whereas code 2 uses a line to depict the charge. The length of the tape is assumed to be evenly charged throughout and includes the dimension of length for the second code, whereas the point charge, which is for the first code, only has a position and no other dimensions. This results in the discrepancies shown within the results of the experiment. Hence, the second code with the line would be more accurate, as it is closer to the real life model. The potential errors for this experiment could have been human errors in measuring physical properties such as length, a changing environment, as different parts of the experiment were conducted at different times. Hence, due to the weird weather where I am right now, may have resulted in changes within the system. Improper handling may have also caused changes in charges, as simply just removing the tape from the table resulted in it being charged. Hence, me using my hand in order to move the tape around may have also resulted in certain changes within the charge of the tape. Through this experiment, we have proved the significance that charges have within our lives. Even in simple activities such as removing tape from a simple desk we still feel their significance. We have employed the Coulomb's law successfully, as we had learned in class. Thank you so much for watching, and please let me know in the comments if you have any questions.